All right, so today we're going to talk about vectors, and I have a little image of Vector from Despicable Me. And if you guys remember, he was committing crime with both direction and magnitude. So that's what a vector has. A lot of times a vector is called a directed line segment. But anyway, I have a graph of a vector. And this vector that I graphed on the coordinate plane is in what's called standard form. And that's when the initial point, so where the vector starts, the initial point is at the origin. And this particular vector, the terminal point is at 2, 5. Right? And then we can use that terminal point to write what's called the component form of a vector. And so the component form has, I call them pointy parentheses, but that's pretty much what they are. And then the numbers inside represent where the terminal point of that vector is. Right? And then the 2 would be considered the horizontal component, and the 5 would be considered the vertical component. Right? There are 2 special vectors that are 1 unit long, and they're called unit vectors. So I has the components 1, 0, and J has the components 0, 1. So we're gonna sketch these real quick. So this green one is I. So it's just 1 unit pointing to the right, and then J is just 1 unit pointing up. Right? And then a lot of times you'll see vectors written in what's called linear combination form, and they use I and J. So if I took that vector V that we've been working with this whole time, that has the components 2, 5, and wrote in linear combination form, it would be 2I plus 5J. All right. And then the magnitude. So remember, a vector has magnitude and direction. So let's talk about magnitude. The magnitude of a vector is the length of the vector. And the notation for magnitude can look like double absolute value. And if we want to find the magnitude of a vector in component form or linear combination form, we're going to use the Pythagorean theorem. And so the magnitude of vector V would be the square root of the horizontal component, which we're going to call A squared, plus the vertical component, which we're going to call B squared. All right. So for our vector that we've been talking about here, this vector that the components are 2, 5, if we wanted to find the magnitude, we would do the square root of 2 squared plus 5 squared, or the square root of 4 plus 25, or the square root of 29. Right. And then another thing that we have to find with a vector is the direction angle. So the direction that this vector is pointing. And the angle of the vector is the angle formed from the positive x-axis. Okay, so this vector, here vector V, this is what we're talking about when we're talking about the direction angle, which is what we're used to when we've been working with angles. All right, so to find theta, the direction angle, we're going to use the formula that the tangent of theta is equal to B over A. B is going to be the vertical component, and A is going to be the horizontal component. Now, sometimes this can definitely get messy when we are outside of quadrant 1, but we're just going to go ahead and use this vector V. So basically, we would say that the tangent of theta would be 5/2, or that theta is the inverse tangent of 5/2. Now, that's not an angle we can figure out with the hand trick, so we would just leave it in that form. But these ones we're going to work with, we should be able to figure out the actual angle. All right, so on example 1, we are going to start off and just sketch the vector that the components are -4, 4. So left 4, up 4. So this is going to be the terminal point. So we will just draw a line segment from the origin to that point, and then we just draw a little arrow. That is vector V. All right, now if we needed to give vector V in linear combination form, we would say that V is equal to -4i plus 4j. And those are not scripted i's and j's, it's just regular, like it's actually bold I and j. Okay, and then we're going to find the magnitude. So the magnitude is basically just the Pythagorean theorem. So 16 plus 16 is the square root of 32, and that's going to reduce down to 4 square root of 2. Okay, so let's look at this direction angle. So what we know is that the tangent of theta is going to be equal to the vertical component. So this is A and this is B, so 4 over -4. Or that the tangent of theta is equal to -1. Now it does make sense that the tangent of theta is negative because vector V is in quadrant 2 and tangent is always negative in quadrant 2. So that's a good sign that we've done something right. Okay. And then if we're looking at the hand trick, for us to take the tangent and get 1, that means there needs to be the same number of bottom fingers as there is top fingers. So that gives us, if we're in degrees, the 45-degree finger. So what that means is that the reference angle is 45 degrees. But the angle we want is the angle from the positive x-axis. So that is theta. So we have to figure out what that angle is. So theta should be 180 minus 45 degrees, or 135 degrees. Okay. Now sometimes we have to subtract to find the angle. So depending on where it is and where your reference angle is, sometimes you would have to add. You'd have to look at each situation individually to figure that out. But it would be good if we knew before, and we will have to continue to review this, what pi/4 is in all of the quadrants. So this one was 3 pi/4, 5 pi/4, and 7 pi/4. It's also going to be good if we know what that is in degrees. So I know that's 45 degrees, but it would be helpful if we also knew in quadrant 2, that's 135 degrees. In quadrant 3, that's 225. And in quadrant 4, it's 315 degrees. So we obviously can do things and figure that out like we just did. But if you know it and you have it memorized, it definitely will save you some time in the long run. All right, there's one more thing we need to talk about, and it's if we know the direction angle and the magnitude of the vector and we want to find the actual vector, a formula to do that. And in the past, this has always been on the challenge exam. So out of everything we're learning about vectors, unless they change the test. This is really the most important part. So if we're looking for vector v, we would take the magnitude of it and multiply it by the cosine of theta, sine of theta. All right, so I'm just going to go ahead and set it up for number 2a. V should be equal to the magnitude of it, which is 2, and then times the component with the horizontal component, the cosine of 300 degrees, and then the sine of 300 degrees. Okay, now I'm going to move down here to the bottom and do a little bit of work, side work. So for our hand trick, we need to know what the reference angle is for 300 degrees. And you may already know that in your head. But we would take 300 degrees and subtract it from 360. So that's going to give us 60 degrees is our finger that we're going to be using. And we also need to remember that 300 degrees is in quadrant 4. So that means that when we do the cosine of 300 degrees, we're going to get a positive. And when we do the sine of 300 degrees, we're going to get a negative. So it's super important. Don't mess that up, please. Okay, so when I do the cosine using my 60-degree finger, I do the square root of the top fingers over 2, which is going to be 1 over 2. And we just said cosine of 300 is positive. All right, the sine of 300 degrees is going to be negative, and we do the square root of the bottom over 2. All right, and then the only thing we have left to do is to distribute that 2. So when I do 2 times 1/2, that's going to be 1. 2 times negative square root of 3 over 2 is going to be negative square root of 3. That's my vector we're looking for. All right, now do double check. Like we said that this is going to be in quadrant 4, so make sure that your components would graph a vector in quadrant 4, and it would. Like you would go right 1 down square root of 3, and there's your vector. So we should be in good shape. Okay. So let's look at this last one. For this vector v, we're going to take the magnitude and multiply it by the cosine of 225 degrees, sine of 225 degrees. Now, if we know we have to do this on our hand trick, we probably already know what finger we're going to use, because if it's a special angle and you're going to use a finger and the angle ends in a 5, then it definitely has to be 45 degrees. But if we went through the whole process of finding the reference angle, 225 is in quadrant 3, and so we would do 225 minus 180, and that is going to give us our 45-degree finger. All right, and like we just said, 225 degrees is in quadrant 3. So that means that the cosine of 225 degrees is going to be negative, and so is the sine. Okay, and so for cosine, we're going to do square root of the top over 2. For sine, we're going to do square root of the bottom over 2. All right, and then there's really not much we can do because the 7 is not going to reduce anything, so it would just be negative 7 square root of 2 over 2 and negative 7 square root of 2 over 2. All right, and then that would definitely graph in quadrant 3 because we do left and down. All right, so this is like a crash course on vectors. So what I want you to do are these 7 problems here at the bottom. And go ahead and do them on the separate sheet because I do want you to graph and do different things.